Hi, this is going to be a series of videos in which we feature the PowerPoint slides from our Hawks software. And we skip a few sections in Chapter 1. We're going to pick up with Section 1.8, Introduction to Integers. Now, throughout these series, you should take notes on it. And there'll be some sections in which we will have a open notes quiz based on these PowerPoint slides. So this is what we'll be doing. So our objectives in our first part here will be to be able to graph a set of integers on a number line, understand and be able to read inequality symbols such as less than and greater than, know the meaning of the absolute value of an integer, and be able to graph an inequality on a number line. Now, throughout this section and throughout these early sections, you could, of course, use your calculator, but you want to try as best possible to be able to do this work mentally and know what's going on. And if you use a calculator, sometimes you put a number in and it doesn't make sense. And you realize you might have made an error putting something into the calculator. So kind of expecting where your number should be and the signs of the number, these are good something to know. Okay, we're going to define on a number line what are integers. And the way they set it up, an integer, and they're using the funny symbol Z here to indicate integers. They're going to start with a ... indicating this is coming from negative infinity here. And then you pick up on the pattern -3, -2, -1, 0, 1, 2, 3. And then it continues to the right to what is called positive infinity. So this would be what we call roster notation for integers. So this is something you would put in your notes. A quiz question might be, what would be the roster notation for integers? And this is what you would write on the answer line. Now, there are other types of numbers on the number line. For instance, natural numbers, whole numbers. We have mentioned integers. And then there's rational numbers and irrational numbers that all fit into the set of numbers we use in math called real numbers. And the only ones you're to know or be aware of at this time is the integers. All right, one of the common operations you're asked to do is to find the opposites of something. So, by definition, the opposite of something is what you add to a number to make it equal 0. And if we had a -5, what do you think we would add to a -5 to make it 0? And the answer is a +5. So, I went the wrong way here. Let's go this way here. There we go. So, to find the opposite of something, if you put the sign, the negative sign in front of something, this is red, the opposite, that first negative sign, the opposite of a -5 is 5. We often you've heard of the double negative makes something a positive. So a negative of a negative is a positive. Or you can look at that as the opposite of a negative is positive. Now, what would be the opposite of a negative 11? And think about it for a moment. And remember, include these in your notes, because these could be quiz questions. The opposite of a negative 11 is a positive 11. Now, how about the opposite of 14? And if you said negative 14, you are correct. And you'll notice they're showing you that intermediate step. Now, of course, you can pause this anytime you like, and even go back, of course, as you could move ahead perhaps more quickly if you know something already, but you'll want to have things in your notes. All right, here they're asking us to graph the set of integers as is indicated in this roster notation. Now, these words, you should include them in your vocabulary. So let's write it down. Roster notation. And that's, you use a brace and you list the elements that you are including in that set of numbers. So roster notation. So we want to put these on a number line, and we do so by having a number line and just putting a dot on each of the integers you are interested in. So this is the way to graph integers on a number line. All right, now how about if they have these little 3 dots there? And by the way, you should have a name for these 3 dots. This is an ellipsis. They had mentioned this earlier in the chapter, but we are jumping ahead a little bit. And the ellipsis, indicated by these 3 dots, means that this pattern continues. And we're going to write that on a number line. And this booklet by 3 dots. Now, we used to, in other ways of indicating that it extends, is just make the arrow a little darker, but in this text, in this software, they're using these 3 dots. And you'll see when you put that into the Hawks software, you'll have to have a little training and a little experience in getting that correct. Okay, so here are the major symbols for order, and this is read less than or equal to, greater than or equal to. Now, to determine whether one of these statements are true or false, we look at what it says. 4 is less than or equal to 12. Now, when we have the equal sign, which is the little dash underneath, in this occasion, only one part of this needs to be true for this statement to be true. 4 is less than 12, so therefore it is true. Now, how about 4 is less than or equal to 4? Well, again, part of this is true. So again, if part of it is true, this is true. 4 is less than or equal to 4. 4 equals 4. That is true. Again, you want to put these in your notes as samples. Now, how about if a statement is false? How do you correct something like this? Well, 4 is not less than 0. So you could correct it by reversing the inequality sign. 4 is greater than 0. Or you could rearrange the order also. Put the 0 on the less side and the 4 on the greater side. How about this one? This is not true. But again, if you reverse the direction of the sign, we could rewrite it as, here it's greater than or equal, reversing it less than or equal, or putting the 0 on this side, as they show here. And again, you'll be doing these in your practice and then later in your certification. All right, another major topic we're going to treat here as background is absolute value. Now, the absolute value signs are these two vertical bars to either side of what we're dealing with. And we're saying the absolute value of something always equals its positive value. Or, if it's a 0, the absolute value of 0 is 0. Now, keep in mind that inside here, this could have been a negative value. So the absolute value of A could have been initially a positive A, or it could have been a negative A. But when it comes out, as we see up here, it's always a positive. I think we went back a little bit there. Checking out this slide once again, it says if A, as we see it, inside there represents a negative 5, then the opposite of a negative 5, as we see here, is a positive 5. And if X is a negative 3, the opposite of a negative 3, as we see here, is a positive 3. We had some of these before, and that's true if Y equals a negative 8. Now, as we look at this, and it can be a little confusing, so we need to be careful, the absolute value of any negative is always its positive value. If you keep that in mind, any value inside these absolute value signs will always be its positive value. The one exception is if it's a 0. 0 is an unsigned number. And it's often explained this way. What is the distance that something is from 0? That's its absolute value. And distance is a positive value. So here, a negative 2 is 2 units from 0, as is a positive 2. And as we mentioned, this is the one exception. 0 is not signed, so the absolute value of 0 is 0. Now, as we look at this, true or false, is the absolute value of a negative 9 less than or equal to 9? And the answer is it's true. Since 9 equals 9, part of that statement is true. So that makes it true. Now, what are the possible values for x here? And keep in mind what we've just said. Well, this x could have been a 7, right? That would have given you a 7. But it also could have been a negative 7. That would have given you a 7 as well. And they're showing you that here. Now, how about this one? This one's kind of a little tricky, so be careful about it. Here we're saying the absolute value of something is equal to a negative. Well, we said before the absolute value of something always is equal to a positive. So this is not a true situation. There are no values for a here that would make this true. Now, how about for something like this? What values would make this true? We want x is greater than or equal to 4. And they want you to graph the values of this on the number line. So what I'm going to do is show you how to do this and take some notes on it as well. Now, the way these are done is we write it first without the absolute value sign. We'll say x is greater or equal to 4. Then we pause for a moment and say, what else could it be? Well, x, we often put an or here, x could also be, and we reverse the inequality signs, we say less than or equal to negative 4. Now, if we were to put these on a number line here, and we can do some over here as well here. This would be like a negative 4 here, and this is a 4 here. Let's do this one first. So x is equal to 4, so we'd put a dot there, and then it would start going up, and then we'd put our ellipsis here, which is indicated by an arrow that's thickened there. And then here, x is less than or equal to negative 5, so we'd put a dot on there, and then an ellipsis going this way. But these values in here, a negative 3, a negative 2, negative 1, 0, 1, 2, 3, these would not be part of this set. So we'll see this in a graph here shortly. Now, notice how they are setting this up in roster notation. They're indicating it with an ellipsis, and then showing the pattern going down to negative 4, but then there are no other values here until it gets to positive 4, and the ellipsis continues then on this end. And in a graph, as I showed you, would look something like this. So again, pause it, get some notes. So if this were a quiz question, you would have your answers in your notes, because they are open notes quizzes. Now, how about this one here? Well, as we look at it, these are solved in a similar way. Let's do it up here. We would say x is less than 4, or x, now we reverse the sign, is greater or equal to -4. This is the protocol, this is the strategy for solving this type of inequality. Take away the absolute signs and just write it, and then this. Now, if we were going to put that on this graph, what would it be? Well, we could start with this one. X is less than 4. Now, we're looking for integers here. So, would I put a dot on 4 here? If it's less than 4? No. The first dot I would put would be on 3. 2, 1, 0, and then I go here. It says x is greater than -4. So there's -4. Greater than -4 would start here, and being greater, the negative numbers would get smaller as they approach this. So this is the proper graphing for something like this, where it's solved in this way, and then this would be the graph of it. So these are the values in the set. We showed you how to get it. Take the absolute value sign away, then reverse the sign, reverse the direction, and say -4, then these are the values that we plot on our number line. And that completes this first part.